Imagine a world where advanced machines don't just rigidly follow pre-programmed instructions, but instead learn from their experiences, adapt dynamically to new situations, and even correct their own mistakes autonomously. This isn't mere science fiction. It's the tangible reality of autonomous AI, a groundbreaking field where artificial intelligence systems are specifically designed to enhance their performance through ongoing self-correction mechanisms. At its very core, autonomous AI learning from mistakes relies on a continuous feedback loop, similar to the way humans reflect on and improve from their own experiences over time. When an AI system encounters an error, it doesn't simply fail and stop. Instead, it meticulously analyzes the discrepancy between its predicted or intended outcome and the actual result observed. This detailed analysis process involves comparing the AI's internal model of the world with real-world observations, pinpointing exactly where its understanding or actions diverge from reality. Take autonomous driving as a concrete example. If a self-driving car misidentifies a stop sign due to unusual lighting or angle, the system logs this error comprehensively for later review. It then leverages this log data to update its neural networks, fine-tuning parameters and weights so that it accurately identifies stop signs in diverse future scenarios. This iterative process is frequently powered by reinforcement learning techniques, where the AI receives positive rewards for correct actions and negative penalties for errors to guide its improvement. Through countless iterations of trial and error across vast data sets, the AI progressively refines its decision-making policies, steadily minimizing the occurrence of mistakes over time. Another powerful method is self-supervised learning, where the AI generates its own training labels or targets directly from vast amounts of unlabeled data without human intervention. If the AI's generated prediction fails to align with the actual input data, this mismatch is flagged as an error, prompting the model to adjust its parameters accordingly. Consider a language model tasked with predicting the next word in a sentence. If its prediction proves incorrect, it learns specifically from that contextual mistake to improve future predictions. This relentless continuous self-correction enables AI systems to function effectively in highly complex and unpredictable real-world environments, all without requiring constant human oversight or intervention. The ability to learn from mistakes proves crucial for AI applications across diverse fields like robotics, healthcare diagnostics, and high-stakes financial trading systems. In robotics, for example, a robot might initially struggle with grasping a delicate or irregularly shaped object, but through repeated attempts and self-correction, it refines its grip strength and technique. In healthcare, AI diagnostic tools can significantly improve their accuracy by learning directly from past misdiagnosis, ultimately contributing to better and more reliable patient outcomes. Financial AI systems, meanwhile, can adapt swiftly to volatile market conditions, drawing lessons from previous trading errors to optimize and refine future investment strategies. This inherent self-improvement capability is precisely what sets autonomous AI apart from traditional, rigidly programmed systems that cannot evolve on their own. Consequently, it empowers AI to address problems that are far too complex, dynamic, or multifaceted for humans to explicitly program solutions for every conceivable scenario. However, this learning process isn't entirely without significant challenges. Ensuring that AI draws the right lessons without amplifying existing biases or errors remains absolutely critical. To address this, developers must implement robust validation techniques, comprehensive testing protocols, and strict ethical guidelines to responsibly steer the AI's learning trajectory. Looking ahead, the future of autonomous AI that learns from its own mistakes holds the promise of truly incredible technological advancements across society. From self-optimizing smart cities managing traffic and energy in real time to highly personalized medicine tailored to individual genetics, the potential applications are both vast and deeply transformative. As these AI systems grow increasingly sophisticated, they will play a pivotal role in shaping our world, making complex decisions and solving intricate problems with unprecedented speed and efficiency. The journey of autonomous AI represents one of continuous evolution, propelled forward by its remarkable innate capacity for self-correction and adaptation. Ultimately, it's a profound testament to human ingenuity, as we create forms of intelligence that can not only learn from data, but also comprehend, acknowledge, and rectify their own imperfections. This ongoing development trajectory will undoubtedly yield more robust, highly reliable, and ultimately far more intelligent artificial systems for the future. Subscribe to AI Blast for more science explained by artificial intelligence.